Hi everyone, Professor Bob Young back at you here with another exciting instructional video, this time on graphing linear inequalities and systems of inequalities. Now, a linear inequality in two variables is an inequality in the form ax plus by is less than or equal to c. And some of you are used to seeing this with linear equations, graphs of lines, the standard form there, but you're used to the equal sign and not these, fun inequalities, where of course a, b, and c are real numbers with a and b not both equal to 0. Now the symbol in this case, less than or equal to, could be replaced with greater than or equal, less than, or greater than. And the graph of a linear inequality is a half plane and perhaps with its boundary, and we'll look at these a little bit more as we move through. So for example, to graph this linear inequality, let's go ahead and act like this 3x minus 2y is less than or equal, is less than or equal to 6. I'm sorry, waking up here this morning, is just an equal sign in here. We'll act like it's equal, and remember, to graph this line in this form, we said the best way was to find the intercept. So first, we'll find the X-Intercept, so we got some good review going here, by letting y be 0, and if you let y be 0 in this inequality here, x will be 2. And of course, to get the y-intercept, you just do the reverse. You let x equal 0 to get your 2 points on the line, solve for y, and you get -3. So you can see here that those 2 points are certainly graphed. All right. Now it says, since the points of the line satisfy the equation, this line is part of the solution set. All right, now here's what we mean by that. And notice I put some notes down here on the bottom. So in these linear inequalities, whenever you're graphing and you're finding the solution sets and so forth, if it's got less than or equal or greater than or equal, you'll get solid line figures. And what this means is that all the points on the graph will satisfy the inequality. So for example, if I take one of these points we did up here, 2, 0, and I plug it in over here in this linear inequality, 3 times 2, okay, I'm plugging 2 in for x, minus 2 times 0, plugging 0 in for y. Let's see if that is less than or equal to 6, and that makes sense to us. So 3 times 2 is 6, is less than or equal to 6. Well, that's true. So any point on this line will make this inequality true. So that is why it's a solid line. Now let me go to a different color because y'all know I love colors here and so forth. On the bottom down here in blue, if there is no equal sign, then you must put a dotted line graph or figure. And that just means that no point on the graph will satisfy the inequality. So for example, if we have 3x minus 2y is less than 6, and it didn't have the equal in there when we checked one of our points up top, we would get a false statement, 6 is less than 6, which is false, so we would have to use dotted line figures. So that just means that those points on the line would not be included. And you're going to see that as we do some more examples here. You know, Young, we always do tons of examples here on this. Now, to decide which half plane, the one above the line 3x minus 2y equals 6 or the one below the line is part of the solution set. Remember, whenever you have inequalities, you get a shade. Oh, I love that shading. You can also solve the original inequality for y. And you've done this in Chapter 3. You've taken standard form and changed it to slope-intercept form to give you more information and so forth. And this is actually great exam review, this problem right here, because I remember a lot of you had trouble with this earlier on the earlier test, so be careful here. So I'm just going to kind of go through this step by step. So to get y by itself, we're going to go ahead and subtract 3x from both sides, which they show in step 2 there, and then divide everything by -2 to solve for y. Now here's where a lot of people had trouble. Whenever you divide an inequality by a negative number, flip it good. Doon, 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 doon. It's not the Whip It song, but the Flip It song. And if you don't flip when you need to flip, your grade gets flipped from A to F. Remember, dividing by inequalities. Be careful. Flip that inequality whenever you multiply or divide an inequality by a negative number. All right, now where to shade this? The solution set of this inequality is all of the region that makes it true. All right, so for this particular inequality, it will be satisfied by all values of y that are greater than or equal to 3/2 x minus 3. All right, so thus the solution set is what's shaded here as part of the answer. Now, if you're not sure where to shade, I mean, it's either going to be one side of the line or the other. Take a checkpoint here, and I'll even go back to this original problem, and I always like to check the point 0, 0, because you can check any point here. So I'm going to plug 3 times 0 in for x minus 2 times 0 for y. Is that less than or equal to 6? Well, you're going to end up with 3 times 0 minus 2 times 0 is 0, is less than or equal to 6. So our friend 0, 0 here, we'll put a big old is true. And what that means is I could have picked any point over here. I could have picked the point -2, 1. I could have picked the point -3, 0. I could have picked any point to infinity over here, and it would have also made this a true statement. All right? Now, any point on this side of the line will not satisfy our inequality. So any point over here, Now, if you don't believe me, let's take a point here. I'm going to check this point for 0. All right? And I will show you that if you plug 4, 0 into this inequality, so we'll plug 4 in for x, so 3 times 4, 0 in for y, minus 2 times 0 is less than or equal to 6, you end up, ladies and gentlemen, with a false statement. So no points on that side of the inequality will work. All right, now it even gets better. A blast from the past. Now they're going to sneak in the old and or statements, if you remember those. And hopefully you do from earlier lessons. And remember, whenever you see this connector matched up with our friend, and some of you missed this on earlier tests, the intersection symbol. Now, what does intersection mean? What the two have in common. We are only going to shade what both of these two lines have in common when we get done here. So you have to know that and means that. Or when I'm graphing more than one line here, another good word I like to use for and is where the graphs overlap. So that's always good as well. So we're going to go ahead and take this first inequality in standard form. And this one's a real easy one to get the intercepts on. So I'm going to let y be 0 over here. I'll go ahead and get the 2 points. And of course, x will be 5 in this one. And then let x be 0 and y will be 5. And we will go ahead and graph this line here. 5, 0, 0, 5. And is it a solid or dotted line? Well, because of this equal sign on the inequality, if you didn't get that earlier, that's what determines solid or dotted. In this case, it's solid. So I'm going to go ahead here and get me a nice solid line in red. Try to make it straight here. My line tool here on the old writing tablet. And let me put some arrows on there. Lines always need arrows. All right. Now, if this were the only thing we were going to graph here, this solid line, which side would we shade on? So what I'm going to do is check, of course, because I'm lazy, and you probably will too, 0, 0 to see if it works or not. So putting in 0 for both x and y, true or false, deal or no deal. I used to love that show, deal or no deal. All right. So in this case, it's true, isn't it? So 0, 0 works. So we would, if that was the only thing we had to graph, shade toward 0, 0. And of course, we could have picked any other ordered pair below that line, and it will also make perfect sense. And of course, any point above that line will not. All right, so that was a standard form problem. notice I gave you one here in slope-intercept form as well. So this is great review here. So on this one, since it's in slope-intercept form, the old y, we're going to act like it's equal there, equals mx plus b. I would start on -2 and go rise over run to get my other point. Rise 1, run 3. So remember, that is how you graph in this form to get your 2 points. So in standard form, you get the 2 points by getting the intercepts, which I think is the easiest way. And of course, you could have solved that first one for y. And in this form, I think it's easier just to do the old slope and y-intercept. Solid or dotted line here, well, this inequality in blue does not have the equal to, so no points on it will satisfy. So we're going to go and I'm sorry I can't make a pretty dotted line like I did the other line there, but that's all right. All right. Guess what point I'm going to use to see where to shade this blue line? Yes, ladies and gentlemen, I am going to check our friend 0, 0. So I'm going to bring this down here, and I'm going to plug 0 in for y. Is 0 greater, and 0 in for x, than 1/3 times 0 minus 2? Well, that gives me 0 is greater than -2, which I do believe is true. So 0, 0 is our friend again. So if I was just shading this dotted line, if it was all by itself, I would shade toward 0, 0. So shade what works, don't shade what don't work. All right, now what is the solution set to these? Well, what do they have in common? Where do they overlap with this AND connector? And I hope you see it's everything below the red line, everything above the blue line. So this area right in here, and I'm going to pick another color here. Y'all know I just love these colors. Green. Let's go ahead. This is the solution set for this pair of inequalities with the AND connector. All right, continuing. What if we had an OR connector in here? You know, Young, I like to do plenty of examples here, so I gave you an OR connector. What does OR mean, Young? Well, OR means union, if you remember, which is not the same as AND. So if you didn't get this earlier, this was a huge concept. Union means not what the two graphs have in common, but to combine graphs together. It's almost like the union of holy matrimony when you get married there. You know, so you have to put everything together. So we're going to go ahead and graph this first line in slope-intercept form again. So we're going to start at 5 and tell me where to go mathematically. Some of you will be out there, I'll tell you where to go, Young. No, but I mean where to go on the next point. So again, we've got a negative slope here. So rise over run, we would go down 3 and over 4. And there is my second point. Solid or dotted line here. Well, the inequality here, it doesn't have the equal to in it, so I'm going to go try to make this as straight as I can here. Don't laugh at my lines. I'll see some of yours too. All right. Let's check 0, 0 here. Where do we shade? Of course, we could check any point. Now, one student asked me, well, what if the line goes through 0, 0? Which was a great question. And I would say, well, take another point. 1, 0, 0, 1, 5, 0, 0, 10, 0 negative to anything but 0, 0. You can also use other points to check. I just use this one because I'm lazy. So if I plug 0 in for y and 0 in for x, I get 0 is greater than 5. That's false, ladies and gentlemen. I don't think 0 is greater than 5 last time I checked. So 0, 0 has failed us here. So we must shade this way. And I bet you if you picked any ordered pair on that side of the line, it would work in that inequality and make perfect sense. All right. Now, how about, let's take a different color here. Let's go pine green on this one. All right. what does the line look like that cuts y at 1 here? Y is less than or equal to 1. Now remember, if you forget which way that line goes, horizontally or vertically, you can make a little table of values here and just put 1, 1, 1 in for y, and then anything you want for x, and you will find that this line is going to be a horizontal line. So any line that cuts y at 1, and I'll try to line this up as best I can here, would go this way. That's not bad. And it is solid. Why? Why is it solid? It's got the equal to, Young. So which way would I shade on this line? Well, since it's less than or equal to 1, all numbers on y less than or equal to 1 would go south or down. All right, so here comes the final answer. When you have an or in there, where do you shade? You must go ahead and let me get a different color here. We'll get a pretty violet or something. You would shade everything this direction, and just combine it together with everything this direction. So there is a huge difference, ladies and gentlemen, between the and the or connector. What do you think? Now notice, had this been an and in this case, we would have only shaded this region, this little region in red right in here, had that been an and. That would have been what the two graphs had in common. All right? But with the OR connector, just combine them and shade everything together. And I think in Math Excel, if you're using that program, there's little buckets you click on and it will shade whole areas for you. So I love those Math Excel ones. That's cool. And last but not least, when solving systems of inequalities, now here's the one as you get farther along in the course and in the chapter, there is no and/or between them. So which one do I know? What do I do, Young? So in this case, if there is no and or, you must know this always means and that is huge. So we'll do one more example here. So as you continue this, and again, we're just graphing lines and figuring out where to shade. If there is no and or, put one. and you must know, again, intersection, what they have in common. So since this is a standard form one here, we'll start out with 4x minus 2y is less than or equal to 8. I'll let y be 0. X is 2. I'll let x be 0. Watch your signs here. Y will be negative 4. Solid line or dotted line. Think about that as I plot these points. And I hope y'all came up with solid. Why? It's got the equal to. All these points on here will work in that inequality. If you plug them in, they would satisfy the inequality. All right. Have y'all figured out where to shade this? We're not going to shade anything yet until we actually get there. So you don't go clicking on the bucket too soon in Math Excel, or you may kick the bucket. Just teasing. All right. Do some mental math for me. Will 0, 0 work in here? I believe you can do that mentally. You'll get 0 is less than or equal to 8, which is true. So we would shade, in this case, toward 0, 0. And if x is less than negative 2, which way does a line go that cuts the x-axis? Well, we just found in a previous example, when it cuts y, it's horizontal. When it cuts x, it's vertical. So I'm going to go through x is negative 2. And know why that's dotted. It doesn't have the equal to. And if x is less than negative 2, it would be all values going this way. So this is great graphing review and so forth. So with the and connector, I'm going to go ahead and get the orange out this time. I haven't used orange to shade. I just like these colors. What do these two have in common? Everything in this plane, as we called it, would get shaded. Everything in here. Now don't go, be careful there. Don't go on that one side of the red line. You have to stay where they both have in common here. So don't shade below there. All right, So Bob Young signing off. Let's hit those graphs and do well and make sure you're shading the right regions and getting the correct lines. I want A's on this next test.